In this lesson, we'll try to answer the question, why should we space out our study sessions? Again, having a little understanding of how the hippocampus is doing its job, that will shed light on this beneficial study technique of spacing out our study sessions. So first, let's recap what's going on when we're studying. Here we have our first study session. The cortex is processing the information, so that's the encoding stage. And some of those neurons in the cortex will be allocated to forming a memory trace for that information. But as well, cortical neurons are sending electrical signals down into the hippocampus, and so the hippocampus will make a nice strong memory trace that links the cortical memory traces. Now, we've also learned in previous lessons that short study sessions are recommended, and this is because continuing a long study session activates the same hippocampal memory traces. And so at some point then, as we study for a longer and longer period of time, we're going to reach a plasticity limit. And we reach a plasticity limit because hippocampal neurons show high plasticity. They grow stronger synapses early in the study session. And as a consequence, then, prolonging our study session, we will not be making further gains in synapse strength, and so that becomes less effective over time. Then when we go to sleep, you'll recall the hippocampal memory traces are reactivated, and they are used to strengthen the cortical memory traces. We said this was consolidation, and this happens during sleep. It's as if when we're learning, the hippocampus is the learner, and then during day, and then by night, the hippocampal memory traces are the teachers. They're going to be teaching the cortical memory traces to strengthen themselves, to represent the learned information. We also learned in another phase of sleep, apparently the hippocampal memory traces are weakened. So synapses are weakened among the hippocampal neurons so as to be refreshed for new learning the next day. And that makes sense. The hippocampus is a small structure. There are a limited number of neurons, limited number of synapses, and we can't learn anything if we can't grow stronger synapses. So we have to reset those synapses back to a baseline level so they can be strengthened again for new learning. Now, let's see why spacing is valuable. And let's consider first spacing out study sessions with sleep. So after a night of sleep, it is more likely then that a different set of neurons will be allocated for the second study session, and they are refreshed because those synapses were weakened during sleep. So you'll notice this hippocampal memory trace. This would be the memory trace formed upon the second study session. Let's compare it to the first hippocampal memory trace. You can see it's a different set of neurons here. So when we study one day and then go to sleep and study a second time the next day, we're likely activating a different set of hippocampal neurons to represent the memory trace for learning the same information. It's going to be the same cortical memory traces being reactivated, but we'll have a different hippocampal memory trace than the original study session the day before. Now, even if it happens to be the same hippocampal neurons that are involved in the second memory trace, they will have been refreshed by sleep. So their synapses were weakened the night before. So even if it is the same hippocampal neurons, they're going to have a better capability of strengthening again when we study that second time. But more likely, it'll be a whole new set of neurons that will be responsible for making the memory trace for the second learning event. Now, let's say you're in a pinch and you need to do your studying in one day. The assessment is the next day. We still want to create delays between our study session. By creating a delay between study sessions, it is more likely that a different set of neurons will be allocated for the second study session. And you can see that in our hippocampus here. So the first study session might be these neurons here, and the second study session, it would be these hippocampal neurons. It's the same cortical memory traces being activated here. The same cortical neurons are activated. But when we take a break, we give the hippocampus a chance to form a different memory trace that links together the same cortical memory traces. And importantly, those different hippocampal neurons are likely to be fresher. That is, they have synapses that are more capable of new growth to represent the learning in that second study session. So what we have basically is if we just prolong one study session, we're going to saturate those synapses. These hippocampal neurons will already have made strong synapses in the early part of the study session. Continuing to study does not produce gains in synapse strength here. If we take a break, we have a chance of allowing a separate set of hippocampal neurons to make the memory trace for that second study session. So breaks make it more likely that different and fresher hippocampal neurons will be allocated to the second study session. Now, to understand why is this that breaks are having this effect, here's one way to take a look at it. We can just try to attempt to answer the question, which hippocampal neurons are being allocated to a study session? What is it that determines which neurons are going to be part of the hippocampal memory trace? And here's one of the ideas that scientists are proposing. They propose that it's the most excitable neurons at any given moment that get allocated to the memory trace in the hippocampus. And scientists have evidence that momentary differences in gene activity can account for momentary differences in excitability. So here we got a bunch of hippocampal neurons, and here's our first study session. Well, which hippocampal neurons are going to be involved in the memory trace? It's the ones that tend to be just the most excitable at that particular time. And so sort of maybe differences in gene expression can account for some of those differences in excitability, and that's why it is that these 3 hippocampal neurons are going to be recruited to make the memory trace for that particular study session. Now, importantly, hippocampal neurons that are recently activated will remain at elevated levels of excitability for a time, because activation of a neuron turns on certain genes that make the neuron more excitable. So once we've activated these neurons to make the memory trace for the first study session, they're going to be at a heightened level of excitability for some time. So that if we just keep on studying and we don't take a break, we're going to be activating the same hippocampal neurons because they are enjoying a heightened level of excitability. So here's the problem of just studying for long periods of time. The hippocampus operates in a way that when you activate hippocampal neurons, they remain in an excitable state. So they're going to be recruited for memory traces for the stuff we're studying, but we've already strengthened their synapses. And so we're not getting any further gains when we just prolong our study sessions. Remember, when we keep studying, we are going to reach a saturation point for synapses. If we take a break, we're going to make it so that new hippocampal neurons are likely to be allocated for the second study session. And again, by taking the break, we're allowing those original hippocampal neurons to lower their level of excitability back to some baseline level so that when we study that second time, it's going to be a different set of hippocampal neurons making the memory trace. And those different neurons are likely to have fresher synapses, which means those synapses haven't already been strengthened due to recently learned information. Now, to see why that's beneficial, let's use this brain here. So here we have brain, we've got some cortical neurons in various sensory areas of the cortex, and we've got our hippocampal neurons down here. And here we're going to engage in our first study session. Well, it's the most excitable hippocampal neurons at that moment that are allocated for the memory trace of event 1. So that's study session number 1. And here we see these 3 hippocampal neurons will be involved in the memory trace. We've also learned that activated hippocampal neurons sustain their elevated excitability and so are more likely to be allocated to event 2, the second study session, if it's a continued study session. So it's really just one long study session. So what happens here, if we just prolong our study session, it's going to be many of the same hippocampal neurons that are being allocated to the memory trace of that prolonged study session, what we're calling event 2, but it's really just one long study session, and we're not taking a break. So long study sessions do not recruit different and fresh hippocampal neurons. Now, when the study sessions are separated in time, the hippocampus can make distinct memory traces for the study sessions, even though they are about the same information. So notice we have 1s and 2s up here in the cortex. That would be study session number 1, study session number 2. But we're studying the same information, so we're activating the same cortical memory traces. But notice the 2 study sessions are creating different hippocampal memory traces, because those study sessions are separated by time. So that is a beneficial effect of spacing out your study sessions. You're making unique and separate hippocampal memory traces that are related to the same cortical memory traces because we're studying the same information. So we can study the same stuff on 2 occasions and make 2 separate hippocampal memory traces, and that then turns out to be beneficial when we go to sleep and do consolidation. So since we have 2 separate hippocampal memory traces that can be fired up, here's the memory trace number 1 from study session number 1, and it gets fired up and it can strengthen the cortical memory traces of study session number 1. But then we also have a hippocampal memory trace number 2 that can be fired up and strengthen the cortical memory trace number 2. But wait, we said study session number 1 and 2 are really about the same information, so we've just got double the effect. Because we spaced out our study sessions, we can have a greater impact in strengthening those cortical memory traces because of the break that we took between study sessions. So, when do we want to study? We want to study when the hippocampal teacher is prepared to learn. And this means reduced synapse strength between hippocampal neurons. When does this occur? After sleep. Or we want to study again when fresh hippocampal neurons capable of synapse growth can be allocated to the memory trace. And when does this occur? This occurs after a delay since the last study session. We allow the original hippocampal neurons to reduce their excitability, and then we'll have a chance to recruit new and fresh hippocampal neurons for that second study session.